Hello and welcome to our session on DevOps for .NET on AWS. I'm your host Taz, a solutions architect at Amazon Web Services. In this session, I will show you how to implement CI/CD pipelines on Azure DevOps and AWS to build and deploy applications to be hosted on Amazon Web Services. We will use the Cloud Development Kit, also known as CDK, to provision infrastructure on AWS from our pipelines, utilizing infrastructure as code approaches. We will also use the AWS toolkit for Azure DevOps to easily integrate with AWS to deploy releases from our Azure pipelines onto Amazon Web Services. Then, after the session, you should be familiar with tools and processes to create CI/CD pipelines, develop, deploy, and maintain infrastructure and applications on AWS. As a prerequisite for the session, I'm going to assume that you have seen our previous video on getting started with .NET on AWS. You have an AWS account available to you and are able to access it via the AWS Web Console. And you have an Azure DevOps account in which you can go ahead and create pipelines. Before we go any further, let's discuss the AWS Cloud Development Kit. CDK is an open source software development framework used to define our cloud application resources using familiar programming languages. In this demo, I'll be using CDK with C# and the .NET Core runtime. CDK will take our C# application code and synthesize it into CloudFormation stacks, which will be deployed onto our AWS environment. What this means is that we can provision our cloud resources with proven defaults in a safe and repeatable manner using programming languages we are already familiar with. This will allow us to start and finish projects a lot faster. Now, for this project, I have uploaded .NET code used into this GitHub repo. We will use this solution throughout the session, so please go ahead and clone this repo onto your local machine. There is a useful README file which describes the solution and its components, and also instructs you on how to install the AWS CLI and CDK onto your local machine. This will be really important for the second half of our session, so please go ahead and run through the installation process. The solution we'll be working with was developed in our previous Getting Started with .NET on AWS session. It consists of 4 components. A .NET Core MVC website called the old web app that will be deployed onto AWS Elastic Beanstalk. A welcome message API, which will be deployed as an AWS Lambda function. A local weather API, which will be deployed as a Dockerized image onto Amazon Elastic Container Service. And also a CDK project, which will be used by our CI/CD pipelines to provision the infrastructure required to host these workloads. Once our pipelines have been created and the solution is successfully deployed, we will be able to load the old web app onto a browser, enter our first name into the text box, and hit the submit button. Once submitted, the old web app will create a post request to the welcome message API to get a result greeting such as "Hi Taz." It will then do a GET request to the local weather API and get a randomly generated weather report. These results will be rendered on the web page to be displayed to the user. So with that context in mind, let's go ahead and start creating our CI/CD pipelines on Azure DevOps and then onto AWS Code Pipelines. Okay, now that we have a high-level understanding of the overall solution, let's go ahead and start implementing our CI/CD pipelines in Azure DevOps. To do this, we will first need to install the AWS toolkit onto our DevOps environment. So go to Browse Marketplace, and you'll be taken to this website here. Then go ahead and type in AWS toolkit in the search bar. Awesome, there it is. Cool. So just verify that it is the AWS toolkit published by Amazon Web Services. And then press the Get It for Free button and go through the installation process. So I've already installed this into my Azure DevOps environment. So I'm going to go back to my Azure DevOps instance and go ahead and create a new project. Call it .NET on AWS. This should go ahead and create a new Azure DevOps project for me to use in hosting my repository and also building and running my pipelines. Very cool. Now that I have a project created, what I want to do is create a service connection between Azure DevOps and my AWS account to which I'll be deploying my workloads to. So let's go to project settings and search for service connections, create service connection, and as you can see, the AWS toolkit has installed an AWS service connection right here. So I'm going to select that and press next. What I need to do now is enter the access key ID and secret access key for an IAM user on AWS, which has sufficient permissions to provision infrastructure on my behalf. I've already got one created, which I'll be reusing. However, in your case, if you don't, create a new IAM user and download the security credentials. And that security credentials file will contain the access key and the secret key as well. So I'm going to go ahead and copy and paste the one I already have at hand. Scroll down, give the service connection a name. I'm going to call it AWS. Awesome. And now my service connection has been created. What I'll do next is start building my pipelines, starting off with the local weather API, and then moving on to my welcome message API and the old web app. Okay, so to start creating the deployment process for our local weather API, we need to first import the code repository from GitHub that we'll be using onto Azure DevOps. So if you go to GitHub and clone the URL, cool, and then go to repos and press the import button, paste in the URL we've just cloned, press the import button, and this will start the import process. The repository will contain a couple of assets which we'll use as part of the deployment for our local weather API. So first, what we're going to do is build a pipeline to build a container image and then push that onto Amazon Elastic Container Registry. And that image will be a Dockerized file containing our deployed application for the local weather API and will be used by Amazon Elastic Container Service to go ahead and pull from and then run it as a containerized task. So let's go to pipelines, create pipeline, use the classic editor, hit continue, and let's select Docker container as the template. Okay, so first things first, let's rename our pipeline to something meaningful. So in this case, I'll call it step 1. Push container image. Okay, so we've got two build actions here, build an image and push an image. Now we don't want to use the default template to push the image, so let's go ahead and remove that and start working on our build image step. So we want to build an image and we want to push it to a container registry, not the Azure container registry. And let's go ahead and select the Docker file, which will be used as a build template. That Docker file can be found inside of our solution. So if we go to Visual Studio, look at the local weather API project, and inside of there, we have a Docker file Azure DevOps. Inside of here, as you can see, we have a couple of commands to start building our application using the .NET build command. And before then, we go ahead and restore all the NuGet packages for .NET Restore. So restore the packages, build the image, and then go ahead and publish the application to be picked up and pushed to ECR. You'll notice the path points to our local weather API project file, which will be contained inside of the local weather API folder. So back to Azure DevOps. Okay, so let's go ahead and select the Docker file. So if you go to our repository, expand source, expand local weather API, scroll down, and we can see Docker file Azure DevOps, and press OK. Now we want to give our image a name, and I'm going to use local weather as the image name. So this is basically the name of the image that will be pushed to ECR. Once that's done, let's go ahead and add a new task. And the task we want is for AWS ECR. Okay, so we want to basically use the Amazon ECR push step to take the image we built in our previous step and push it into our AWS environment onto ECR. So let's select that. We select the AWS credentials we defined in our service connection earlier on. we select the appropriate region. I'm using the US East 1 region, also known as North Virginia. I want to go ahead and make sure that I use the same source image name as I specified earlier, which is local weather. And also, I want to give the repository that'll host this image a name as well. I'll just reuse local weather for that. And I want to say that if the repository does not exist, go ahead and create it. And also enforce any kind of naming conventions for Docker. Cool. So that's all done. Let's go ahead and save this now. Awesome. So we basically created a pipeline to build a Dockerized image of our application and then push it onto ECR. Let's go ahead and hit the Q button and run that process. So this will trigger our build pipeline. And once the build agent finishes, we should be able to log into our AWS account and go to Amazon Elastic Container Registry and basically see the Docker image pushed onto AWS. I've just gotten a warning to say I'm using a version of Ubuntu for my build agent, which will soon be deprecated. So I'll just make a point to not use that version anymore in the subsequent build steps and upgrade this one to version 20.04, which I believe is the latest on Azure DevOps. Hey. So the build process and the deployment process to push the image onto AWS has completed successfully. Let's quickly have a look at what happened. So inside of our build agent on Azure DevOps, we've got the build an image step. And inside of there, we can see a couple of things have occurred. We have restored the NuGet packages for our local weather API project. We've done that by running the .NET restore command right over here. Then our Docker file had run the .NET build command to build the project out and then push it onto an image. Once that was done, the push image step had executed, which basically took the image we'd built and pushed it onto AWS, onto ECR. And here's a link for the ECR repository where our Docker image is stored. As you can see, we have called the image the local weather image, and also it has received a tag called latest. Cool. So let's go over to AWS and have a look at what's happened. So if I search for ECR, which is Elastic Container Registry, we should be able to see that a new repository has been created. So we've got a repository called local weather. Awesome. And now we also have an image with the image tag of latest. So great. That means the first step in our CI/CD pipeline has completed correctly. Let's go ahead and build another pipeline to build and deploy the infrastructure to host this image, and also then pull this image from ECR onto ECS. Okay, let's go ahead and start building the pipeline to provision our ECS environment and pull the repository image we just pushed onto ECS. And hopefully by the end of it, we will have our local weather API running. So back to pipelines. Let's create a new pipeline. Use the classic editor. Continue. I'm going to search for the .NET Core template. So if I type in core in the search bar and use ASP.NET Core, that'll give me a couple of predefined steps which I'm going to recycle. Now, I'm not going to worry about tests or the publish commands right now. So I'll go ahead and remove those. But what I'm going to do is rename my pipeline to something more meaningful. So step 2, deploy ECS. Great. And I want to go ahead and use the latest version of Ubuntu. And what I also want to do is make sure that the project that this build pipeline will look at is my Getting Started CDK project folder. So if I open up my repos, and under source, I have a folder called Getting Started CDK. So I'm going to go ahead and expand that. And go to Local Weather API. And then inside of there, I have a CDK stack, which will go ahead and provision the ECS environment for me. So let's have a look at the stack really quickly. So first off, what the stack does is says find an ECR registry called local weather. Then from there, pull a container image, which is tagged to be the latest. Then once the image is gotten, go ahead and start using the ECS patterns construct inside of CDK to provision me a new ECS environment that'll be backed by Fargate. So what this patterns library does, it takes away a lot of the heavy lifting from me when it comes to provisioning an ECS service. So it will go ahead and provision me a new VPC with an ECS cluster, and inside the cluster will be an ECS service. And that service will run tasks, which will basically run the image I had defined earlier. Then, once the ECS environment is provisioned, a load balancer will be provisioned to front that environment. And inside of there, we go ahead and add a health check for the local weather API URL. And this will make sure that if the APIs are unhealthy, the load balancer can go ahead and provision new instances of that task to run in our ECS environment. So let's grab the path to the CDK folder, go back to our pipeline, and paste it in. Great. And then build and restore. You can see over here, we've got the path to our project. So I'm going to quickly save that. Okay. Now what I'm going to do is add a couple of steps to execute some shell commands. And those shell commands will basically install CDK onto the build agent server and then synthesize my CDK stack to make sure that it is formed correctly. And if that synthesize step finishes correctly, the second shell command, which I'm going to add now, will go ahead and run the CDK deploy action, which will synthesize my C# code into a CloudFormation stack and then deploy that onto my AWS environment. Those scripts are kept inside of the CDK project. So again, back to getting started CDK. And then if you look at the local weather service inside of there, you've got two shell scripts. Let's copy the commands from the install CDK shell script. Inline, paste it in, use the credentials we defined earlier and run this in US East 1. Awesome. The second shell step, same thing again, add the credentials, select the region, inline script, back to my repo, copy, and paste. Okay, so what's going to happen is basically when CDK deploy runs, we're going to pass it through a parameter to find a particular CDK stack to execute, and then also put in a switch to say, don't require me to manually approve the deployment in command line. And this means we can automate the deployment process. If I quickly go back to my .NET solution, inside of there, if I go into Getting Started CDK project and open up the program CS file, you will see that I have an instantiation of that CDK infra stack, and that stack is called Azure DevOps ECS stack. And that should match the CDK deploy command here. So CDK deploy, Azure DevOps ECS stack. Awesome. So let's go ahead and save that. And this should be good to run now. So I'm going to go ahead and hit the Q button, run. All right. And now let's wait for the pipeline to finish. And once it's finished, we log into our AWS console, and I'll show you exactly what's been provisioned. Okay, so it looks like the deploy pipeline for our ECS environment has finished running now. And if I go to my shell script, I can see that basically my stack was deployed and various different CloudFormation steps were generated and executed, about 40 steps in all. So if I go to my AWS account now and search for ECS, I should see a cluster, a service, and some tasks running as well. Cool, so I have a local weather cluster, and I have a local weather service running. And inside of there, I have 3 tasks. Brilliant, that aligns with what we should expect. Now, what I need to do also is check the Elastic Load Balancer to see if that's been provisioned and get the DNS name so we can go ahead and invoke this API. So search for EC2. Okay, scroll down and click on Load Balancers. Cool, so there's a local weather Elastic Load Balancer provision, and it's given me a DNS name, which I'll use in a second to invoke the API. Now let's have a look at our target groups and ensure that the health check we have specified for our application is in there. So if I click on that, I can see I have 3 healthy tasks running. And then if I go to health checks, brilliant, my health check for the local weather API has been configured correctly. So let's go ahead and call our API now. Okay, so paste in the load balancer name with the API resource name, which is local weather. Awesome. So it's giving me a weather report back. It's raining and the weather in your region is raining. Quickly refresh it. Another randomly generated report, overcast. The weather in your region is overcast. Brilliant. So what's happened here is we've created a CI/CD pipeline, which takes a CDK stack, synthesizes it, and deploys it onto AWS using shell commands. Awesome. So now let's go ahead and create a pipeline to deploy our Lambda API, which is the welcome message API, onto AWS. Okay, so let's go ahead and create a CI/CD pipeline to deploy our Lambda API. So I'm just going to create new pipeline, use classic editor, continue, and let's search for .NET Core. So search for core, select ASP.NET Core, and again, we get a template back. For this one here, I am again removing the test and publish steps. Okay, remove, and I want to go ahead and add a step to push my Lambda. So if I search for AWS Lambda, okay, I should get a package installed by AWS Toolkit called AWS Lambda.NET Core. So add it to my solution. Now, what I need to do first off is give this pipeline a meaningful name. So I'm going to call it step 3 deploy Lambda. Select the latest version of Ubuntu. And I also need to go ahead and specify the project where my source code for my API will be stored. So back to my repo, welcome message API, copy that path, paste it in. Cool, quickly save that. Okay, so I'm going to leave the restore and build steps alone and start modifying the deploy.NET core to Lambda step. So inside of here, I'm going to select the AWS credentials we'd specified earlier and select the region, US East 1. And it's quite important, since I'm using the serverless application model for my Lambda function, I'll go ahead and select serverless application and also select where my Lambda project resides. Cool. I want to give my Lambda project a stack name, and that stack name will represent what my CloudFormation stack will be called on AWS. So let's type in Azure DevOps Lambda. And also, once the code is built in my build steps and then pushed to AWS, it will need an S3 bucket to go and land in. That code will then be pulled from S3 and used for our serverless application. So I've already created a bucket in my AWS environment called welcome message API S3 bucket. If you haven't got one, go ahead and create a private bucket and then paste the name into here. Don't worry about the prefix and hit the save button. Cool. And then with that, we should now be able to go ahead and run our build, and this should deploy the Lambda application onto our AWS environment. What will happen is that the Lambda function will be compiled using the serverless application model, and it'll use the serverless.template file to do a couple of things. First off, it will go ahead and configure the API to sit behind the AWS API gateway with the following settings. And also, I've defined a parameter store to go ahead and put the API URL into a parameter store, and that'll be used later on by the old web app. Cool. So we'll wait for the build agent to finish running, and then I will go ahead and log into the AWS account and show you what's been provisioned. Okay, so it looks like our serverless application deploy process has finished. So let's head over to our AWS account and search for Lambda. Cool. Great, and if you click on applications, you will see that there is a new Lambda function deployed called Azure DevOps Lambda. So let's go ahead and click on that. And we will see there's an endpoint URL specified, which we can use to carry out post requests against the API to basically get a welcome message back. Also, if we go over to CloudFormation, we should be able to see a CloudFormation stack, which was created as part of the deploy process. Okay, so we can see the older ECS stack that was created by CDK. And now we can see a Azure DevOps Lambda stack that was created by the serverless application model when our application was built and deployed onto AWS. So now let's go ahead and call this API by using Postman, and hopefully we'll get some results back. Ready. So we've got Postman, which is loaded up now. I'll paste in the new URL for our Lambda function. And then also the API resource parameters, such as /API welcome message. There's a body being sent to the API called Batman. And if this works, I should get a welcome message back for Batman, something like, hey, Batman. There we go, hey, Batman. Let's try it again for Taz. Send. Awesome, hey, Taz. So cool. Now that we've confirmed that both of our APIs have been deployed, one onto ECS and one onto Lambda, let's go ahead and deploy the old web app, which will invoke these APIs and generate a welcome message and a weather report for us. Now we're going to deploy our Beanstalk environment in a similar manner to what we did for the ECS environment as well. First, we'll create a pipeline to go ahead and provision the infrastructure for Elastic Beanstalk. And then we'll take our application and create a pipeline to build that application and deploy it onto the environment we had just provisioned. So let's go ahead and start the pipeline creation for creating our Elastic Beanstalk environment on AWS. So create new pipeline, classic editor, continue, and let's search for core again and use the ASP.NET Core template. Okay, remove the test steps and remove the publish steps. Awesome. So let's go ahead and give our pipeline a meaningful name. So I'm going to call it step 4 provision Beanstalk. And then let's go ahead and copy and paste in the path for our CDK project. Okay, so source, getting started CDK, great. And now, similar to what we did for ECS, I'm going to go ahead and add 2 shell script commands. The first command to synthesize our CDK stack, and the second command to deploy our CDK stack. So switch that to inline script. And back in our repository, if we go back to getting started, CDK bash scripts, old weather app scripts, let's go ahead and copy the install CDK shell script commands, paste them in, assign the credentials and regions. US East 1. Awesome. And now let's go ahead and copy in the CDK deploy commands. Very cool. And again, we're going to be deploying the stack we have inside of our project called Azure DevOps Beanstalk stack, along with the never approve command line switch. Awesome. So let's go ahead and save that. And with this, we should now be able to run our CDK stack, which will go ahead and provision our infrastructure. So hit Q, hit run. Okay, so the build agent has started. So I'm going to basically come back to this now once the deployment has finished, and then run through the AWS environment to describe what has been provisioned on AWS. Okay, so it looks like our pipeline has successfully deployed our Elastic Beanstalk environment onto AWS. So if you go to our web console on AWS and type in Elastic Beanstalk, we should be able to see an Elastic Beanstalk environment which is now available to us. Cool. So we have the old web app environment along with the URL to get to the web workloads hosted on there. Right now, there should just be a default application that gets deployed onto Elastic Beanstalk because we have not specified our pipelines steps to push our old web app onto it. And also, if we go to CloudFormation, we should see that a stack has been created to provision the infrastructure that we've just seen. Very cool. Azure DevOps Elastic Beanstalk. So if we hop back to our solution inside of Visual Studio, we'll see that basically our CDK deploy command had invoked the old web app infrastack. And that infrastack does a couple of things. What it does first off is create a couple of roles to be used by our Elastic Beanstalk instances, assigns the permissions to basically access SSM, and also we have defined a few settings for Nginx, which is the web server of choice for Linux workloads that I've selected, to basically say, go ahead and service or surface style sheets and JavaScript objects or assets onto our web browser when a website is called and the relevant assets need to be sent across. Cool. And also this Elastic Beanstalk instance is a Linux-based instance running the .NET Core runtime. So with this now, we have an environment that is ready to have our application deployed onto it. So let's go ahead and do that now. So if you go back to our pipelines. Okay, so let's go ahead and create a pipeline to deploy our old web application onto the infrastructure we have just provisioned. So new pipeline. Classic editor. Continue, search for core. Very cool. Let's remove the test step. And also let's go ahead and add a new step in here called Beanstalk. Cool. Use the deploy Beanstalk app step. Add that, move it to the right place in the pipeline actions. Very cool. So first off, I'll rename the pipeline. Step 5, deploy old web app. Very cool. Latest version of Ubuntu, and then inside of the deploy Beanstalk step, let's go ahead and select the region. It's the credentials we had selected earlier, and the US East 1 region. And now what we need to do is add a couple of settings that match up to what we have specified in our CDK stack. So application name needs to be old web app. Our environment, old web app environment, which is what we saw in the AWS web console. Let's go ahead and select ASP.NET Core Linux and put in the path that has our published asset. So if you go back to publish artifact, you'll see that when the code is built and published onto Azure DevOps, ready to be pushed onto AWS, the publish path is basically the system parameter here, which is what we've pasted in, along with a old web app.zip name, which will be basically the asset once it's been zipped up by our pipeline. Okay, I think we're ready to go now. So let's go ahead and save this. Okay, and queue the build. Cool. So what I'll do is come back once the deployment has finished and then walk you through the deployed assets, and we can then go ahead and test out our website to see what it looks like once it's been fully deployed from Azure DevOps onto AWS. Okay, so it looks like our application has built and deployed successfully. So let's go ahead and go to our AWS console and search for that. So if we go to Beanstalk, okay, so the environment is healthy. And let's go ahead and open up our website in a new browser tab. I'll just do a refresh. Awesome. So our website is ready to go. So let's test it out. Type in Taz, submit. Brilliant. Hey Taz, the weather in your region is overcast. Excellent. So basically what we've done right now is deployed out our application onto the Beanstalk environment published in step 4. And overall though, what we have done is created a series of CI/CD pipelines from Azure DevOps to build and deploy applications onto AWS, along with the CDK and the serverless application model to provision infrastructure on our behalf. As you saw, CDK and the serverless application model can really help simplify the infrastructure provisioning process. And the AWS toolkit really helps out with Azure DevOps interactivity with AWS. So now we've finished this, let's go ahead and repeat this similar kind of process on AWS using AWS code pipelines to create our CI/CD pipelines for the same application stack. Okay, now we are ready to create our CI/CD pipelines in AWS using AWS code pipeline and CDK. So before carrying on, please go ahead and delete all of the CloudFormation stacks that we created from our Azure DevOps deployments. And then once that's done, please go ahead and clone the repo from GitHub onto AWS Code Commit. I have done the same thing inside of my AWS account, and I've also made it a point to keep the same structure as is inside of the GitHub repo. So I have a repository called .NET on AWS, and inside of there I have my relevant bits of code and configuration as per the GitHub repo. Very cool. Okay, so once you have done that, let's go ahead and open up the solution on your local machine. And if you go to Getting Started CDK project and open up the program.cs class, you will see 3 stacks that we'll be using as this part of the process. The first stack provisions our container registry and our ECS environment. Then we also have a stack to go ahead and provision our Lambda serverless function, and the same again for our old web app, which will be hosted on Elastic Beanstalk. So let's go into a bit of detail on the ECS ECR pipeline stack. So this stack does a couple of things. First off, it accesses the repository where our local weather API code base is stored. And then it goes ahead and provisions an ECS cluster along with the relevant services and tasks that will run our workload. We have some permissions assigned to that cluster to allow us to access ECR to pull from the repository and also create logs on our behalf. As you've seen before in the previous stack, we also have some health checks against the load balancer to make sure that our tasks are healthy. And just for illustrative purposes, I've also defined some scaling rules to define auto-scaling policies against the ECS cluster. Now we get to the crux of it, where we go ahead and define our build project and also define the steps inside of CDK to create our CI/CD pipeline. So the first thing we do is create a build project, which will read from a build spec YAML file and orchestrate the build of our code. So if you have a look at here, we have a build spec file specified that this step will access. And that build spec file basically gets a token for ECR and then creates a Docker build and then pushes the Dockerized image onto ECR. The Docker build process looks at a Docker file inside of our local weather API project. And if we go to that quickly, we will see we basically have some .NET restore commands run, a .NET build command run, and a .NET publish command run, which basically compiles and publishes our local weather API ready to be pushed into ECR. So if we go back to the pipeline stack, once the build project is defined, we go ahead and assign that to our CI/CD pipeline inside of code pipeline. So what we do first is assign some roles that will be used for code pipeline, and go ahead and define some actions for code pipeline. Actions are basically steps inside of our CI/CD pipeline. So first we get our source code from our repository. Then we go ahead and execute the build configuration we'd specified earlier on. Then we go ahead and deploy that application. So all of those actions are assigned to a code pipeline configuration, which I've called pipeline here. So I define a new object called pipeline and then assign the actions to it. So get the source code, build the application, and then deploy the application. Awesome. So that's the ECS ECR part of things. Let's go ahead and have a look at how we build and deploy our Lambda project from AWS code pipeline. So again, very similar steps. First off, we have a look at our code commit repository. We create a bucket to go ahead and host the Lambda code once it's published. We have some roles being assigned to build the project and access code pipeline. And over here, just to show you a couple of different options, rather than specify a build spec.yaml file, I have basically configured a build spec file from an object inside of the build project. And this basically does a couple of things. It installs the Amazon Lambda Tools.NET runtimes onto our build server. Sorry, here it is. And then we go ahead and use the serverless application model to package our Lambda application based on the serverless.template file, which we had seen earlier on in the Azure DevOps part of the project. Very cool. And then we go ahead and define our actions. So get source, build project, and create a change set in CloudFormation, and then go ahead and execute that change set. Then we build a new pipeline and assign those actions to it. So get source, build, create a change set, and then deploy the change set. Awesome. So with that in mind, let's go ahead and start basically synthesizing and deploying the CDK stacks from our local machine onto AWS to create our pipeline and then also build and deploy our applications as well. Okay, so to synthesize and deploy our CDK code, let's go ahead and open up the command line and navigate to the root folder of our source repository. Cool. So if you see the cdk.json file, you're in the right spot. And then what we're going to go ahead and do first is synthesize and deploy the ECS ECR pipeline stack, and then quickly go ahead and do the same thing for the Lambda and the Elastic Beanstalk stack as well. So assuming you have followed the steps on the GitHub repo README file and installed the AWS CLI and the AWS CDK onto your local machine, this should work just fine. So the commands we'll be using is cdk synth, and let's paste in the stack name. And this will go ahead and basically synthesize our C# application into a CloudFormation script. And if it runs correctly, that means that we are able to go ahead and run the cdk deploy command and successfully deploy our stack onto AWS to create the pipeline and provision the infrastructure. Cool. So it looks like our synth command has finished correctly. And if you scroll up a little bit in your console, you'll see that we have a whole bunch of CloudFormation script automatically generated for us by CDK. So let's go ahead and run the cdk deploy command now to publish this onto AWS. So cdk deploy, paste in the stack name, and then this will start the deployment process now. Awesome. So what's happened here is that we've gotten a summary of the actions that the cdk deploy command will carry out on our behalf. It talks to the resources and the permissions against them that this stack will create. So typically it's a good idea to review them. In the interest of time though, I'll just say, yes, I do want to deploy these changes. And now the deployment process will kick off. Okay, so it looks like our CDK stack for our ECS environment has finished running successfully. So let's go ahead and have a look at our AWS console and see what's happened. So inside of my console, if I go along to code pipeline, I will see that I have a new CI/CD pipeline created, which is currently in progress. So this pipeline will contain the actions that I mentioned earlier, where we get some source code, we carry out a build, and then we go ahead and carry out a deployment process. So I'll let this process finish and also go ahead and run the same deployment command, cdk deploy, for the Lambda project for the welcome message API, along with the Elastic Beanstalk project, which is the old web app. And by the end of it, we should be able to see that we'll have 3 CI/CD pipelines available to us inside of Code Pipeline, and we should be able to access the old web app and then carry out the actions required to go ahead and enter a name and then get a welcome message and a randomly generated with report back. Awesome. Okay, so I finished deploying all 3 stacks now, and then if I go to Code Pipeline, I can see after doing a quick refresh that I have 3 pipelines defined, and also they have all succeeded being built correctly. So if I go to my AWS web console and search for Elastic Beanstalk, I should be able to access my old my old web app, and hopefully we can enter our name and get a welcome message back. So let's try Bob, submit. And here we are. Hey Bob, the weather in your region is sunny. Awesome. So let's do a quick recap on what we've done. First off, we had CDK stacks, which were synthesized and deployed onto AWS. These stacks did a couple of things. First off, they created an AWS code pipeline, 3 of them, one for each of our applications, which built and deployed our applications onto AWS. The CDK stack also had instructions to provision the underlying infrastructure to host our applications, which the applications were subsequently built and deployed onto. So basically, using C# code, we've created our CI/CD pipelines end-to-end, which provisioned infrastructure, built our code, and deployed that onto the infrastructure previously provisioned. So thank you for watching this video on DevOps for .NET on AWS. I thought to share out some additional reading materials which may be useful as you start implementing .NET workloads on AWS. The first is a developing and deploying .NET applications on AWS white paper. And then also there's some information on the AWS Toolkit, which is a handy extension for both Azure DevOps and your Visual Studio IDE. We also have a builder's guide for building .NET applications on AWS, which shares common architectural practices and some common reference architecture, which may be useful to you, along with a link to the AWS Cloud Development Kit, and also a link to the repository we used in this session. These slides will be shared out to you after the session, so please go ahead and feel free to download it. And again, if you have any further questions, feel free to reach out to your account team or myself on social media. I'd be more than happy to talk about this in any more detail you require. Thanks a lot.